Hello, welcome to Chapter 9, homework questions 17 through 23. Question 17. Solve the following quadratic equations by factoring and using the zero product property. Be sure to check your solutions. So it's telling us specifically which method we are using. We're going to use the zero product property, which means we need to factor so that we can set it up. We also have to make sure our equations are equal to 0. So in the first one, it is equal to 0. We have x squared minus 13x plus 42 is equal to 0. So we need to figure out what the length and width of the rectangle would be. So we'll use our generic rectangle to set up. We got our x squared, 1x squared tile and 42 1 tiles. And so we're looking for what are some factors of 42x squared that are going to add to give us negative 13x tiles. And so as you look at your factors of 42, negative 6x and negative 7x, will allow us to get the product of 42x squared and then add the sum to get negative 13x. So those are the two values that we'll use to split up our x tiles. And then now we're able to find the length and width based on that information. So this now factors to x minus 6 and x minus 7. Still equal to 0. Now we can use the zero product property. And that states if you multiply two or more numbers together, that gives you 0. One of those numbers must be 0. One of those factors, I should say, must be equal to 0. So that's why we set them equal to 0. We add 6, add 7, and so we get two values. And so since it's asking us to solve, I'm going to write this as a set of 6 and 7. You can also say x equals 6 or x equals 7. So either one of these would be a correct way to write the solution. Moving on to part B, now we have 0 equals, I'm just going to move the 0 to the other side, 3x squared plus 10x minus a equals 0. Once again, setting up our generic rectangle where we have 3x squared tiles and we have negative 8 1 tiles, and we're looking for factors of negative 24x squared that add to give us 10x tiles. So, what are factors? We got 12 and 2, and so because we're trying to get a negative 24, we need to make one of them negative, so 12x minus 2x is 10x, and 12x times negative 2x is negative 24x squared. So then we can plug in that information into our generic rectangle, and then this side is going to have to be 3x because it goes into the 12, so that'll work, and then this side will be x. So 3x times 4 gives you 12x, and x times negative 2 gives you negative 2x squared. 4 times negative 2 does give us our negative 8 tiles. So that looks like it does work. So we will factor to x plus 4 and 3x minus 2. Once again, two factors that are equal to 0. The product of the two factors are equal to 0. So we can use our zero product property to say that one of these must be 0 for this to work out. So x could equal negative 4. Add 2, divide by 3. X is equal to 2/3. So once again, we can say x equals negative 4 or x equals 2/3. Or we can write it as a solution set x equals negative 4 comma 2/3, but once again, make sure you use the curly brackets, not parentheses. Okay, moving on to C. We have 2x squared minus 10x is equal to 0. So once again, setting up the generic rectangle, we have 2x squared. We have 0, 1 tiles, so we're going to put a 0 down in the box here. That means our factor, 2x squared times 0 would be, our product, would be equal to 0x squared, and then the sum has to be negative 10x, because that's how many x tiles we have. So what multiplies to give us 0, but adds to give us negative 10x? It has to be 0 times negative 10, but then that adds to negative 10. So we are going to place those two expressions in the generic rectangle. And so we would have a 2x here and an x here. And 2x times Negative 5 would be negative 10x, and then x times 0 would be 0x. So looks like we can write our factor as 2x, and that's just one term. And I guess if you wanted to put a 2x plus 0 there, that's fine. And then an x minus 5. And then once again, we'll set our factors equal to 0, because we know the product is equal to 0, so one of them must equal 0. It looks like 2x is equal to 0, divide by 2, x is 0, add the 5. So x is equal to 0, or x is equal to 5. So you could write that, or once again, we can write it in a solution set. Alright, and on to the last one, D. D, we have 4x squared plus 8x minus 60 equals 0. So before I get started with my generic rectangle, I do notice that 2 does go into all of those, but does also 4, because 4 goes into 4, 4 goes into 8. The question is, does 4 go into 60? And it does. So what we can do is we can actually take out, using the distributive property, we're going to factor out the 4. So 4x squared divided by 4 is x squared. 8x divided by 4 is 2x. 60 divided by 4, negative 60 divided by 4 is negative 15. So that just makes, when we go to do our generic rectangle, a little bit easier to do so the numbers are not so large. So now we're looking at an x squared, a negative 15, and then what are factors of negative 15x squared that add to give us 2x? And so that's going to be 5x and negative 3x. And then from there, once again, find the length and width of the generic rectangle. This is going to have to be a plus 5. Down here will be a minus 3. And so we still have the 4, but now we have the factor x plus 5 and x minus 3. Still equal to 0 though. Now we have 3 factors. 4 cannot equal 0, so that's not going to help us get any solutions, but x plus 5 could equal 0, or x minus 3 could equal 0. So we could have x equals negative 5, or x equals 3, or once again we could write it this way. The solutions of x are negative 5 and 3. So either one of those, once again, will work. Now, going back, I guess I never completely answered the question because it does say be sure to check your solutions. So I'm not going to go back and do all these, but if you want to check your solutions, for example, on A, if I wanted to check this, I would plug 6 back into the equation, which would be 6 squared minus 13 times 6 plus 42. Does that equal 0? So 36 minus 78 plus 42. Is that equal to 0? So we get negative 42 plus 42 equals 0, so 0 is equal to 0. So that checks to make sure it's true, but you would also do it with your other solution, 7. So 7 squared minus 13 times 7 plus 42 is equal to 0, and if you multiply and add those up, you'll get 0 equals 0 as well. So that's how you can check your solutions when you go and solve, is the same way you do with linear. You plug them back in and see if they are equivalent on the left and the right side. Question 18. Use the quadratic formula to solve x squared minus 13x plus 42 equals 0. Did your solution match the solution from part A of 9-17? So this is the same question from the previous problem, but we're just going to solve it a different way. So we have x squared, and that's a 1x squared, minus 13x plus 42 is equal to 0. Remember, when we're using the quadratic equation, we need our equation, the quadratic formula, we need our equation in standard form. So in this case, it is in standard form. The a is 1, the b is negative 13, and the c is 42. So let's also recall the quadratic equation is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we're going to plug the information in. X equals the opposite of b plus or minus the square root of b squared, and since b is a negative, make sure we get it in parentheses, minus 4 times a times c divided by 2 times a, or 2 times 1. And then you need to simplify. So the opposite of negative 13 is 13, plus or minus the square root. Negative 13 times negative 13 is 169. And then on this, make sure you multiply those three numbers, including the negative. So that's negative 4 times 1 times 42. And that is negative 168 divided by 2 times 1. And that is 2. And then continue to simplify. So x equals 13 plus or minus the square root of 1 over 2. So therefore we have x equals 13 plus or minus the square root of 1 is 1 over 2. I'm going to go ahead and separate the plus or minus so we can see both parts. We're going to do 13 minus 1 first, divide that by 2. And then second we'll do 13 plus 1 and then divide that by 2. 13 minus 1 is 12. 12 divided by 2 is 6. 13 plus 1 is 14. 14 divided by 2 is 7. So our solutions are x equals 6 or 7. And to go back and check what we did on the same question, which was A, we got our solutions as 6 and 7. So we did kind of verify that what we did on question 17 was correct with the zero product property and factoring, and then this one we used the quadratic formula to solve, but yeah, our solution should be the same. It doesn't matter the method we use, we should still get the same solutions, and we could check those by plugging those back in just like we did before. Question 19. Does a quadratic equation always have two real solutions? That is, does a parabola always intersect the x-axis twice? If possible, draw an example of a parabola that only intersects the x-axis once. So really on the first part, it does ask a question, does a quadratic equation always have two real solutions? And the answer to that is no. And we'll kind of answer that in part A. If possible, draw an example of a parabola that only intersects the x-axis once. So if it's only going to intersect the x-axis or touch the x-axis, it's going to go down, it's not going to cross, and then it'll go right back up. So it's only going to touch at one point. Same thing can happen if it opens down, but it's only going to once again touch the x-axis one time. B, what does it mean if the quadratic equation has no solution? Draw a possible parabola that would cause this to happen. Well, to have no solutions, then the parabola will not intersect the x-axis at all. So instead of going down and crossing it, this parabola will never cross the x-axis, so therefore there are no solutions. And same thing could happen on the other side. You could go and do something like this. Now it crosses the y-intercept, but it doesn't cross the x-intercept, so both of these would be considered no solutions. There are no values of x that make y equal to 0. Question 20. Find the equation of the line through the point negative 2a with a slope of 1/2. So going back to linear equations, we know that the slope is 1/2, so that's your m, your rate of change. We also have a point xy that the line goes through. So we're going to plug in the information that we have. Y is equal to 8, m is 1/2, x is negative 2, and that'll allow us to solve for b, which is the y-intercept. So 1/2 times negative 2 is negative 1, add 1 to the other side, and b is equal to 9. Now we have enough information now because the slope was given to us, which is the m, and now we found the b value, or the y-intercept, is 9. So now we can rewrite the equation y equals m, which is 1/2, times x, and then plus 9. So that's the equation of the line going through the point negative 2, 8, with a slope of 1/2. Question 21. For each quadratic function below, use the idea of completing the square to write it in graphing form. Then state the vertex of each parabola. So as a reminder, graphing form is y equals a times x minus h squared plus k. And when it's in this form, the vertex is h comma k. Okay, so that's what we want to do. So on part A, we have f of x equals x squared plus 4x plus 5. So to complete the square, we have our x squared. Our 4x's are going to get broken up into two parts because remember, we want this length to be the same as this length. That's what makes it a square. And so when we complete the square, we have 2 times 2, which is 4. So there needs to be a 4 right here. But you can see that we actually have a 5. So if we need a 4 and we have a 5, how do we get there? Well, if we take and we subtract 1, so we have a 5 and we subtract 1, that will get us the 4 that we need. So if we, on this one we have to add, or we have to subtract 1 to this side, then we have to subtract 1 to this side. And so what that would give us is f of x minus 1 equals, now this will be x plus 2 squared, and then we'll add the 1 back on to the other side to get f of x equals x plus 2 quantity squared plus 1. And so that's the form that we need, and then it wants us to state the vertex of the parabola. So the vertex, if you see x plus 2, that's negative 2, and then the plus 1 is just plus 1. So your vertex is at negative 2, 1. Alright, let's try B. So on this one, the constant is 0. You have an x squared minus a 6x. So when we set this up in our generic rectangle, we have an x squared. The minus 6x has to get broken up into 2 equal parts, so that's negative 3x and negative 3x. So we know our side lengths are going to be x minus 3 and x minus 3. So therefore, how many tiles do we need? Well, we need 9 positive tiles. Negative 3 times negative 3 gives us an area of 9. So right now we have nothing. So we need to make sure that we add 9 to this side to complete the square, and then add 9 to this side. So that'll be f of x plus 9 is equal to, now we're going to write this as length times width, so that's x minus 3 squared. And now we can subtract the 9 to get f of x by itself. So f of x is equal to x minus 3 squared minus 9. And the vertex on this one, since it's x minus 3, that's a positive 3, and then minus 9 would be a negative 9. So 3, negative 9 is your vertex for that one. On part C, it says, in both graphs, does the vertex represent the max or the min value of the parabola? Well, how do the graphs open up? Okay, and so how do we tell that? Well, when this value right here is positive, the graph will open up. And so both of these have a positive 1. So the graph is going to open up. So your vertex right here, is that going to be a maximum point or a minimum point? Okay, and you can see that it's going to be a minimum. It's not going to go any lower than that. It'll get bigger, but it won't get any smaller. So that means it will be a minimum value of the parabola. Question 22. The increased demand for vegetarian meals has caused an increase in the price of tofu. If the current cost of $2.99 per pound is increasing 6% per year, what will it cost in 5 years? So let's go ahead and write an equation for the information that is given. It does tell us that there is an increase in the price of tofu, and the current cost is $2.99 per pound. It's also increasing 6% per year. So remember, we're starting at 100%, but it's increasing 6%. So that's actually 106%, or as a multiplier, 1.06. So we have the multiplier. We also need the initial, but that's the $2.99 of the current cost. And so we're able to write an equation based on those two pieces of information, and then we'll answer the question. So y is equal to the initial, $2.99, times the multiplier, 1.06, and then raised to the x power. We should also indicate that what are the variables? Let x represent the time, and the time is happening in years. It says per year. And then we also need to let y equal the cost of the tofu per pound. per pound. All right, so now we can go ahead and plug in and solve the equation, which is for 5 years. So 2.99 times 1.06 raised to the 5th power. Plug that into your equation, and let's see what we get. And we get a y value of 4.00, and then it goes a little farther, 129. But since we are doing, we're dealing with money here, we would say that the cost, we would round it to the nearest cent, and that would be $4 per pound of tofu in 5 years. And that, remember, is the predicted value based on the information. And so I went ahead and added is predicted in 5 years. Question 23. Decide if the statements below are true, false. If necessary, review the descriptions for the inequality symbols in lesson 9.2.1 math notes box. So these are your less than symbols. And if it has the line below, then it's equal to also. And these are your greater than symbols. And I guess it's technically how you also read. But if we're reading left to right, that would be the case. So, part A, is 11 less than negative 13? So all of this stuff, we're really looking at a number line. 11's over here, negative 13's over here. So 11 is not less than 13. It is greater than, or negative 13, sorry. So this is false. On B, we have 5 times 2, which is 10. So is 10 greater than or equal to 10? That is a true statement. On 13, if you simplify this, this would be negative 3 times negative 4, which is 12. So is 13 greater than 12? That is true. On D, we have 4 less than or equal to 4. That is true. It is equal to. 9 greater than or equal to negative 9. That is true. It is greater than. It's not equal to, but it is greater than. Negative 2 is greater than negative 2. That is false. It's not greater than. It's equal to, but it's not greater than. So it is false. Negative 16 is less than negative 15. Sometimes we get confused with the negatives, but once again, think of a number line. Here's negative 15 and here's negative 16. Negative 16 is smaller than negative 15. So is negative 16 less than negative 15? Yes, that is true. And is 0, here's 0, here's 6. Is 0 greater than 6? No, that is a false statement. And so that ends the homework for this lesson.